Hello, my name is Rob Garner. I'm a software development instructor, and today I'm going to talk about branching with Git. So this chapter covers branching and merging, branch management, workflows, and how to deal with remote branches. So what is branching? In a nutshell, it's basically the ability to create a copy of your repo that you can work on while still retaining access to your repo in its previous state. And often development teams will have a number of standard branches that they will create in order to manage their development process. So you will have typically a main branch, then you might have a development branch, and a QA branch. And usually the developers are working off the development branch. And when you want to add a new capability to the application, you'll actually also create feature branches that you'll work on and then merge those back into your dev branch, then from your dev branch, your QA branch, and then to your main branch. So Git doesn't store data as a series of change sets or differences, but instead as a series of snapshots. So when you make a commit, Git stores a commit object that basically contains a pointer to a snapshot of the content you staged. So in a sense, a branch is a pointer to a particular commit. And so during a commit, Git will checksum each subdirectory, stores those objects in a repo, and it creates a commit object in its database that has the metadata, and it creates a pointer to the root project tree so it can recreate that snapshot when needed. And so in your Git repository, you have a blob for the contents of each of your files, a tree that lists the contents of your directory, and a commit with a pointer to the root tree and all the commit metadata. So it might look something like this. So we have a commit, and we have multiple, we have several objects here. The tree is pointing to each one of those, and then the commit is pointing to the tree. And so as you go along and you make new commits, each commit stores a pointer to the commit that came before it. So here you have snapshot A. Snapshot B actually points to its predecessor, and snapshot C points to its predecessor. So a branch in Git is simply a pointer that points to one of the commits. So the default branch name in Git is main. When we created our project, we saw that it was named main. And as you start making more commits, your main branch will keep pointing to the last commit. And so every time you commit, your current branch moves forward. So it's always pointing at the last commit. And so here you can see we have the main branch, and we have a version 1 branch. And there's all our snapshots. And notice that everything is pointing to the last snapshot. So you can have multiple branches that point to either the same snapshot or different snapshots. And there's also this head pointer that Git maintains, which is pointing to the current branch that you're working on. So what happens if you create a new branch? Basically, if you make a new branch, a new branch is based on a previous branch. So you always start off with main. If you make a new one, for example, testing, in this case, testing is made off of main. Since main points to this commit, F30AB, testing is currently already pointing to that. And then how does Git know which branch you're on? It's this head pointer that points to the current branch. So in this case, we're on main. You can see this by running a git log command that shows where the branch branches are pointing. So if you say git log one line decorate, it'll tell you, you know, where the current head block is pointing. So let's try this out. So I'm going to do a git log. And we can see we have our main branch. Head is pointing at the main branch right now. We also have origin main and origin head that are referenced here. They're all pointing at this commit right here where we added comments. So there's all the commits that we did working up till now, and everything currently is pointing to the last commit. So let's make a new branch. And typically, we would have, in addition to main, we would have a dev branch. So I'm going to say git branch dev, and then rerun my command. Now you can see that we now have our dev branch. We're still pointing at main, but we have an additional branch that's created. In addition to a dev branch, we also typically have a QA branch. So I'm going to say git branch QA. And now we have a QA branch. So we can add branches, and all these branches are now pointing at this commit. So currently we're on the main branch, and usually though, what we want to do is we want to do all of our modifications in the dev branch, and then merge from the dev branch to the QA branch, and then merge from the QA branch to the main branch. And the main branch is where we may have the branch. That's where we deploy from. So we want to check out a different branch. We use git checkout and then the branch name. So I'm going to check out the dev branch. And then rerun my log command, and you'll see now we can see that head is pointed to dev. So QA and main are still pointing to this, and we are now on the dev branch. Now, let's say we made a change. So I'm going to add another file. And then I'm going to do git status. I'm going to do git add everything, git commit -a-m. And so we're on the dev branch. We've made a commit. Let's see what happens when we check our log again. And there you see that now dev is one ahead of QA and main. We've made a modification and we're ahead. So what this looks like is this. We now have a branch which is ahead of the other one. So the head points to the current branch. Current branch is ahead of main. So any branches that are not the head isn't pointing to will remain where they are until we do a merge. So now we have our subsequent commits are now going to diverge from the from what we have there. So notice that the head branch moves when we do a commit. The main branches and any other branches stay put. Only the one that you're currently working on moves forward. So can you go back to a previous commit? Yes, you can. So we can do that with the command git checkout main. So let's give that a shot too. So I'm going to do git checkout main and see what happens. Notice that our file disappeared. Oh no, it's gone. But that's because we are on the main branch. And the main branch did not have that file. That commit is in the dev branch. So if we do a log check, you can see we're now pointing at main. There's a QA branch. Let's do a git checkout dev. And we see that the file that's in dev is returned. And if we look at our git log, we can see we're now on the head branch. So you could switch back and forth between different branches and get back to its previous state. So when you check out a branch, it does two things. Moves the head pointer to point to the branch that's specified. So when we went back to main, it pointed to main. And then it reverts the files in your working directory back to the snapshot of that branch. Now here's an important point. Changes you make from this point forward will diverge from that version of the project. And also, you're going to want to make sure that you save that when you switch branches, that the files in your working directory will change. And so if you change branches, you want to make sure that you've committed all your current work before switching branches. Otherwise, you can lose files. So the git checkout command does two things. It moves the head pointer to the branch you specify, and then it reverts the files in your working directory. And changes from this point forward will diverge from that version of the project. One thing to note is that when you switch branches, files in your working directory will change. So if you switch in older branches, you could potentially lose something if you don't have it committed yet. So always make sure you commit your current work before switching branches. So I'm going to return to the dev branch. Or I guess I'm already on the dev branch. So a common thing that happens when you're on the dev branch is you may make a feature branch. So we're going to git branch feature 1. And so here we are, we're on feature 1, and I'm going to check out feature 1. And so now heads pointing to feature one, and I'm going to make I'm going to add a new file to make some changes. And I'm going to git commit or git add first, and then git commit -m and we can see now we're on feature one. We added feature one. Dev is behind us now by one. Main is behind by two. And then we already did the commit. And you can see we're on feature one, we're clear. And now what I'm going to do is I'm going to get checkout dev again. And so now we're back on dev. And notice that feature one is invisible here because dev is behind. And I'm going to make another branch. Let's say we're now a different developer, and they're going to make some modifications. And they're going to start with dev. They don't have access to feature one. We're working on feature one. So all developers, when they make a new feature, start off with the dev branch. So let's say that they're making feature two. And so here we are, dev. Now I'm going to check out feature two. And we're now on feature two. Then the next thing we're going to do is notice that we don't have feature one in here. I'm going to add a new file. And so I've made feature two, and I'm going to git add that new feature. If we look at this, we're on feature two. And look at the commit history. You don't see feature one here. You just see feature two. Now watch what happens when I check out feature one branch. Feature two file disappeared and feature one file showed up. So now those two branches have diverged. Now we just see feature two. And if I check out dev, you can see dev has neither of those features. So we have basically we have dev, and then we have a feature one and a feature two that have diverged. So this is a different example, but it kind of shows the same concept here. We have a main branch, a testing branch, and they've diverged. They are not in the same line anymore. There's a change made to main here, and there's a change made to testing, and they're now separate from each other. So the git log command can show us the history. So if we run git log one line decorate graph all, we will see everything. So let's try that here. Git log one line decorate graph and all. So we could see it's showing us this divergent right here for us. We have feature one and feature two, which are diverging off of dev. Everything else is kind of in line right up till we get to there. So note that a branch in Git is in actuality a simple file that contains the 40 character checksum of the commit it points to. They're cheap to create. They're really just a pointer. And so it only takes 41 bytes of information to create a branch. So you can use branches to really manage your work. And in our cases, typically what a software dev team will do is they will have that main QA and dev branch, which are kind of the standard branches that are always pointing to where we are in our development. And then developers make feature branches, get them to work, and then merge them back into the dev branch. This contrasts with maybe older version control systems where when you made a branch, everything was copied over. In Git, it's just a pointer. So we did some branching here, but the next thing is we need to add merging. So your typical workflow is you do work on a website, you create a branch for a new story you're working on, you do some work in that branch, and then when you need to change a previous branch, you switch to your production branch, create a branch, add a hotfix, for example, and then after it's tested, you merge those branches into the main production line. And you switch back and forth between branches, and so you're constantly switching branches and merging. So here's one concept of doing it. You have your main branch, which is pointing at commit 2. You decide that you're going to work on issue number 53 and whatever tracking system you're using. And so you can actually check out and create a branch simultaneously by using the checkout command with the -b switch. So we've been creating a branch and then checking out. You can do it all in one line with this. So this is really kind of more what you're going to want to do. You're going to do it, get checkout, and then you will do -b for branch, and then your commit node. So you've decided you're going to work on issue 53, and to create that branch and switch to it, you can run this command, git checkout -b, and this will both check it out and then also it'll create the branch, and then it will check it out. So this is a convenient way of doing this, so you don't have to run two commands. So this is the same thing as saying git branch ISS 53 and then check out ISS 53. And what that does is it makes its branch, and it actually will point the head at ISS 53. So then you do some work, and you can see now we're ahead of main by 1. And so let's say then you have a need for a hot fix. So there's an issue with the website. You need to fix the hot fix. And this could be kind of challenging if you had to deploy the feature that it wasn't completed yet along with your hot fix. So what you can do is you can switch back to your main branch and then do your hotfix in the main branch and deploy that. Now, one thing to remember is before switching back, if you have any uncommitted changes, you're going to want to make sure that you commit all your changes before you go back to your previous branch. And so when you switch back, as we saw, your working directory looks like it did the way it was at that last commit. So in this case, if you're switching back to main, it would look like main. And so here you are, you're on main and you do a hotfix. And then this is another example of how you could get to where you have a divergent branches, where the feature branch does not have the hotfix, but the main branch now does. So this is where the merge command comes in. You can make sure the hotfix is deployed, and then you could use the merge command to merge the hotfix into main. So in this case, what they're doing is they're checking out main, and then when you do a merge hotfix, this will take all the changes that are in the hotfix and bring it into main. And you'll see that it says fast forward. So that means that now main will be pointing to the same branch as the hotfix. So first you switch the branch that you want to merge into, and then you merge into that hotfix. So if we look at this now, we can see that main is pointing, it has the changes that were done in the hotfix. So main has the correction. The feature branch does not. So what do we do? Well, so after your fix is deployed, you're ready to switch back to the work you were doing before. However, first you can at this point delete your hotfix branch, because now that's in main and main is pointing it. So you can say git branch -d hotfix. That deletes that hotfix. And now it looks like this. So here you are, you're back on the feature branch, and maybe you did another change. Main is pointing here. So what happens next? Well, do you need to merge that hotfix into your feature? You probably do, because that was an error that created a problem. So you can plan on bringing that in later. So this is where we are now in 53. And they have a common ancestor, which is C2. But this is where we want to merge into. So this is so instead of just moving a branch pointer forward, what you do in this case, when you merge 53 in, what Git does is it creates a new commit, and this is called a merge commit, that merges everything in. So now what happens is, rather than merging into C4, we're merging into C5. And so Git determines the best common ancestor to use for its base of the merge, and then it takes care of this merge for you. So it used to be you had to figure that out. Git does it for you. So sometimes it doesn't work well, and you get some merge conflicts. So let's try, before we go into merge conflicts, let's try this out. So here we are, we have feature 1, feature 2, and we're going to merge. Feature 1 is ready to merge back into dev. So what we'll do is we'll do we are already in dev, so we'll do a git merge feature 1. And so so here we are, we're still on dev. Feature 1's been installed. We have this feature 1 file. And then, so let's take a look at what our log looks like. And you see now dev has moved along this branch. And now we have feature 2. And let's say we want to merge into feature 2. We're still pointing at dev, so I'm going to do a git merge feature 2. And you can see it's made a commit. And that's because we're doing this merge. So it's already given me merge branch feature 2 into dev. And it creates this wait file for me. The way I set it up, it does that. Yours may not do that. I just delete them for now. I really need to get rid of that. But we now have feature 2 merged into dev. And normally when you do a merge, you see that when we first just merged feature 1, there was no need to create a commit, a merge commit for that, because it was all along the same line. Because feature 2 is divergent, it creates that merge commit. And you can see now everything, feature 1 and feature 2 have now been successfully merged to dev. Everything's back in. So this is a typical scenario that you'll get. You will have situations where two developers will merge from the dev branch, they'll do their own work, and then they'll have to merge them in at different times. Now, what if you have a merge conflict? So in that case, we didn't have a merge conflict because the two files were completely separate. But let's say they both modify, you have two changes that modify the same file. In that case, you will get a conflict. And if you get a conflict, then you'll get notification that there's a merge conflict when you try to merge them. And it tells you to fix the conflicts and then run git commit again. And so the way the merge conflicts happens is it's going to be in the same file, and it's going to give you this nomenclature. So this is kind of sometimes difficult to see, but basically think about the way this works is it has these less than signs, and it tells you which branch or which commit this is associated with. This is the head commit. And then this down here is what's in the other file. And then it gives you that. So what you have to do is go through the file if you're doing this manually, and you'll need to edit this and change it to what you want it to be. And so typically you take that out, probably pick this one, and then you'll make the change so that it looks, so that you resolve the problem. And then after you resolve each of these sections, you'll do a git add, and then you'll stage the files, and then you'll do another commit to commit the change. And the final merge commit will look like this. So let's try that out. So what I'm going to do is I'm going to create a new branch. Let's say we're back on dev, and we have a developer that wants to work on feature 3. And so you can see now we have feature 3, and then I'm going to check it out. And so now head is pointing feature 3. And then in here, I'm going to create a new file. And in this file, we'll save that. And if I do git status, you can see, okay, we've got this. I'm doing git add. And so we're on feature 3. Now I'm going to pretend that I'm the other developer, and I'm going to check out dev again. And so the other dev is on 4, and they have a task to work on a feature as well. So they're going to create and I'm going to use the short form here. I'm going to do a -b, git checkout -b, feature 4. And let's see, let's take a look what this looks like. Yeah, so we have 3 and 4, which are divergent. Let's take a look at feature 3 again. And we named it merge conflict.txt. Copy that. And so let's say, just by happenstance, this developer happened to make a file that had the same name. So next, let's look at where we are. Or actually, before we do that, let's add and commit this. And so here we have 3 and 4, they've diverged. There's dev back here. And so if I go back to dev, we don't have that branch. If I check out feature 3, we have this document that looks like that. And then if I do a git checkout feature 4, we have a document that looks like that. So we've got 2 documents with the same name. They have different stuff in them. So now let's say feature 4 decides they're ready to merge back in with dev, and so they do a git checkout dev git merge feature 4. And it works just fine. Here's dev. It's got the feature 4 stuff. And we see dev is up here with feature 4 on this commit. Feature 3 is on this commit, which diverges. Now we are still in dev, and let's say feature 3 is ready to merge into dev. And so we now do a git merge feature 3. And it says we have a conflict. Merge conflict and merge conflict.txt. And it's telling us it can't do the merge because we have this conflict. And if we look at it, there's that nomenclature. This is what's in the head, which is what's in dev, and this is what's in feature 3. And it's basically telling you, Git is telling you, I can't resolve this. Let's take a look at the log. And you can see nothing's been merged yet. Dev is still pointing here, but it looks like this. So how do we resolve this? Well, what we do is go in here and we edit this. And we could either keep this one, we could keep this one, we could make something completely different, or we could keep both. And that's what I'm going to do. This is created by feature 3. This is stuff from feature, or that's feature 4, that's feature 3, and maybe I want these to be in order, so I stack them like this. And then I save this. And so this is now resolved. Let's do a get status. So when I made that change, now this is changed. So I now need to do a get add. I think it's already added. And then a get dash mer or get commit dash a dash m resolved merge conflict between 3 and 4. So that's now committed, and let's see what we look like. And now we have 3 and 4 have been successfully merged into dev. So that's how you resolve a conflict when two developers happen to be modifying the same file. And that will happen periodically too. So that's a typical merge conflict. So we have the fundamentals of how we work with branches. We know how to create them. We know how to check things into branches. We know how how they can diverge. We know how to merge them back together. We know how to resolve merge conflicts. The next thing is branch management. So there's some tools we can use that come in handy when we want to when we're using branches. And the first one is if we just put get branch, we get a list of all of the branches. So let's try that. And there we have all of the branches that we currently have. We have 4 feature branches and we have main, and we might decide at this point that actually we don't need some of these branches. And so we might decide, you know what, now that we've got all those merged in, we don't need the feature branches. And so we can say get branch -d feature 1. And if we look at this, we can see feature 1 is no longer there. At least notice the commit's still here, but the branch is gone. So often so some companies will keep all of the feature branches in. Others will delete them at certain points in time. Others will have the developers immediately delete the feature branch. And usually you can just delete unnecessary feature branches when you don't need them. And that may keep things a little bit cleaner. So I'm going to delete these extra feature branches. And so now we just have the dev, the QA, and the main. So you can use that branch command to see where your branches are. -v, you can see the last commit on each branch. You can also do -merged to see all the branches that have been merged in. And then no merged. This is probably useful to see branches that you haven't merged. So some branching workflows. How do we use these? So you can have several branches that are always open and that you use for different stages. Those would be long-running branches. In our example, the dev, main, and QA branches are our long-running branches. And so this is an example of, Here's your main branch. Here's your develop branch. This is a topic branch. So this would be a short branch that would exist to create a feature and then would be merged back into develop. And then main and develop. Develop is always in front of QA. QA is always in front of main. And so this is another view of how this might work. And so the idea of these long-running branches is in order to kind of have they usually represent a natural workflow for a company. So in our example, we have the QA main branches down here. At this point, let's say that we've merged everything in that we wanted to make and we're ready to have this tested. What would happen then is the dev admin would typically merge the dev branch into QA, or would just notify QA that dev is ready for testing, and then the QA lead would merge the dev branch into it. So it might be something like this. Check out QA. So I'm the QA lead. Oh, git checkout. So picky. So I'm now on the heads on the QA branch, and then the QA lead would then merge the dev branch into QA. QA now looks like the dev branch. We could see now QA's up here with everything in, and they would then the QA branch would do their testing. They would run everything. They would see if there's any errors. If there's any problems, they would send in bug fixes to dev, and then dev already has their branch, so they would merge any fixes into dev and then tell QA, okay, it's ready, and QA would then pull in dev, and that would go back and forth until QA was satisfied with the branch. And then at that point, then it'd be ready for deployment. So QA would tell ops that it's ready for deployment, and then ops would do the same thing. Ops would check out main. We could see here now we're pointing at main, and then would do a git merge QA. And we can see now main is up to date. And then at this point, the ops branch would deploy the application. If it's a website, it'd be deployed. If it's a PC app, then it would go to maybe a store or something. So basically, then the deployment would be done, and everything is up there. Meanwhile, while it's happening, typically dev is continuing on to make new capabilities. So that's a typical branching strategy with 3 main long-running branches: main, QA, and dev. Also, at this point, main may also decide to make a feature branch or a release branch. So the ops team may, after they release it and successfully released, they may and they would just do this to preserve that release. That way, as you make another really changes, if there's ever a problem, they need to revert back to a previous release. This would preserve this commit so that you can come back to it, knowing that had released successfully. So you may have multiple long-running branches. So main, dev, and QA are long-running branches. There's also And you saw that our feature branches, sometimes called topic branches, are short-lived branches that we create to make a feature, and then we once they're merged back into dev, typically you delete those right away. So let's say we have some people doing some work on main. They branch off of, well, in our case, normally it would be dev. They branch off an issue, and then another person branches off another one. And so you may have something that looks like this. You have main, you have these multiple branches, and actually sometimes, and I've done this, I'm working on a branch, I wanted to try something out. I will make a second branch off of a feature just to go down one line, and you might decide, sometimes you might abandon those and say, you know what, I didn't like any of that, and then go back and keep working on the original feature branch. And then sometimes maybe someone wants to do a what if, so they make a branch and they work on that what if. They don't, and the nice thing is that you can do that without affecting the main branch. So these branches are very, very useful. And so, yeah, you could, in this case, they really like the dumb idea. And so they merged that one in. And then they want version 2, so they merged that one in. So you can be very flexible when you use these branches. So at this point, all these changes we did are actually on our local machine. We have not done anything with a remote branch. If we look on the server, we just have the main branch. Nothing else was added in here. It just sees one branch. There's no history in this yet at all. So right now, everything we've done at this point has been on this one machine. In actuality, what would be happening is, as we did a feature branch, we'd be pushing it to the server. Someone else would be pulling that down. And they would be doing some changes, then they push it. So we would also, in addition to these changes, we'd be pushing and pulling things up and down from the server. So, and on the server, it also has current pointers. In fact, we can see that if we do this. If we do a get log, notice here on our local machine, main, QA, and dev are all the way up at this commit, but origin main and origin head are here. Origin only has this one branch. It doesn't have the main, dev, and QA branches. So how do we address that? Yeah, we saw that, the remote name origin and then the branch name main was how that was presented. And so how do we deal with that? Well, when we clone, we brought down that main branch. And that means that there's a main on the original computer or on the server, and there's a main on our local branch. Then we made a bunch of changes, and on our computer, we have main that's at a later commit than the origin. So we can do a fetch, and fetch updates everything. So let's see what that looks like. Let's do fetch gets us the status that's on the server. So if someone else changed something on the server, we would get that. And that's where you actually can get these merge conflicts. But then we want to share what we've done. We can use a push. And so you could say get push origin, and we can push specific branches. and then if we whatever we push, if someone then fetches, they will get our changes at that point. And let's see. And we can also push our changes. We can push a specific one. You can also just hit get push. And that pushed everything up to the server. So now the server is up to date. If I refresh the server now, actually, we just have the main branch. But what we do have is, let's see, let's look at activity. Yeah, we have all of these. We have all of these changes that we've done on the main branch. We would have to actually push dev, and let's see if that worked. Yep, now we have the main and the dev branch. And then I could push the QA branch. And typically you want the dev and the QA branches, all your long running branches up on your server. In fact, the normal process is you create, for example, a dev branch, and then you typically immediately push it up to the server. You make changes, and as you make changes to the dev QA branches, you will push those after you make changes. You can delete remote branches by doing a push origin with the delete option, and that will delete the remote branches. You can also just go on to GitHub and delete them there. And then when you're on a different machine, you use the git pull command to bring everything down. Notice that git pull will also bring down all the history and status from the server. Okay, so that is the basics of branching and merging in Git. Typically what happens is you do have a main, dev, and QA branch. And at the minimum, I recommend having a main and a dev branch when you're working on things. I keep the main branch kind of pristine. And even if I'm just working on a project myself and I don't have a team, I will typically make a main, dev, and QA branch, and I will make feature branches off my dev, make changes on it, and then merge them in. Usually because that ensures that if I ever need to go back to something, it's there. So that is my presentation on branching and merging. Thank you very much.